the area under a normal curve. Our objective, we want to find, using StatCrunch, and interpret the area under a normal curve. Let's remind ourselves of a couple of things we already know. Number one, the total area under the normal curve is equal to 1. Number two, if x is a normally distributed random variable, the area under the curve, the area under the normal curve, represents two things: the proportion of the population with the characteristic described by the interval of values, and the probability that a randomly selected individual from the population will have the characteristic described by the interval of values. So, StatCrunch allows us to find this area under the curve. It's a nice little calculator for that, and it goes, the thread to get there is stat calculator's normal. It allows us to find the area under the normal curve, and thus the proportion of the population with the characteristic, this part, or the probability that a randomly selected individual will have the characteristic, that part. Let's take a look. This is nice and straightforward, particularly with a calculator like StatCrunch. Let me get myself ready over here. Okay, a pediatrician obtains the heights of her 3-year-old female patients. So we got lots of 3-year-old girls, and determines that the heights are approximately normally distributed. Again, that makes sense. My guess is that 3-year-olds are all kind of around the same average height, with a mean of 38.72 inches and a standard deviation of 3.17 inches. Part A, let's draw the normal curve and then shade the area that indicates the proportion of 3-year-old females that have a height less than 35 inches. So we'll keep this simple, letter A. Let's see here. I'm going to try to, I don't have a whole lot of space down here. So I think what I'll do is I'll do B and C over here. So we'll kind of put A down over here, and then I'll put B and C off to the right half of the paper. So here is the normal curve. That's an okay drawing. We're not looking for perfection. And by no stretch of the imagination is my, whoa, that's even worse. Wow. By no stretch of the imagination is my drawing perfect. There's the normal. We have a mean right in the middle of 38.72 inches, just a little over 3 feet, with a standard deviation of 3.17. So we'll go out one standard deviation, we'll add 3.17, which is 41.89, and we could continue if we wanted to mark off +2, +3, and we'll subtract one standard deviation. And when we subtract 3.17 from 38.72, we get 35.55, if I'm not mistaken. Okay, shade the area that indicates the proportion, which is the same as the area underneath the curve, of 3-year-olds less than 35. Well, here's 35.55. So our line is just to the left of that, and I'll put a little arrow indicating this is 35 inches. And we want to shade that area over here. And of course, as we know, it goes on forever, but that indicates the proportion of 3-year-old females that have a height less than 35 inches. Letter B. I'll put letter B over here. Use StatCrunch to determine the proportion of 3-year-old females that have a height less than 35 inches. In other words, what is the size of this area? The entire area is 1. What is the area of this part? And StatCrunch will give us that area. Let's go to StatCrunch. And I've opened up a fresh sheet. Don't need to worry about any data. I just want to use its normal calculator. So I will go to Stat, calculators, and I'll go to normal. This is alphabetically. There's normal right there. Whoops, I think I hit the wrong thing. Did I hit normal? Let me close that. I'm not sure I hit normal. Stat, calculators, normal. There we go. So there's my normal distribution. In this case, the default is a mean of 0 and a standard deviation of 1. So let's change that. We have a mean of 38.72. So we'll put in 38.72. We have a standard deviation of 3.17. And we want to know what is the area under the curve when our values are less than 35 inches. I don't think that gets just a pure less than, so we'll leave it there. We'll go down to here and put in 35 inches. And we'll do compute. And look at that. It's shaded just like what we drew. There's 35. It's not showing... here's the mean. It's not showing the tick marks we included. It's not showing one standard deviation below or above, but it is giving us that area that is to the left of 35, that is less than 35, and that area is 0.1203. Look right down here, 0.1203 to the 10,000th place. So, the proportion of 3-year-old females that have a height of less than 35 inches is 0.1203. Let me double check to make sure. Yes, that's the proportion. Okay, use StatCrunch to find the probability. Now remember, that area under the curve tells us the proportion and the probability. Okay, so we just found the proportion. All right, and this is saying use StatCrunch to find the probability that a randomly selected 3-year-old girl is between 35 and 40 inches tall. And then we're going to interpret this result. So let's go back here to StatCrunch. We've already got our data in. We can use the same mean and standard deviation. Maybe I can open it up a little. Yeah, there we go. Same, but now we want to be between. So I got to go over to here and choose the between option right here, so that when I come down here, I can put it between two things. And I want it to be between 35 inches and 40 inches. And I'll press compute. And take a look at the graph. The area under the curve gives us both the proportion and the probability. And this is a nice shading between 35 and 40. There's your area, a little bit to the right of the mean and quite a bit to the left of the mean. And what is that probability? That probability is 0.5365. 0.5365. So let's jot that down. Letter C, the answer is 5365. We're going to interpret it, which means we're going to have to put some language in there. And this tells us the probability. That a randomly selected three-year-old girl is between 35 and 40 inches. Okay, is 0.5365. If you want to express that in a percent, there's a 53.65% probability that the randomly selected girl will be between 35 and 40 inches tall. So StatCrunch does a lot of neat things for you. It shows us the picture. It also gives us the results either above or below, as well as in between. And that, as a reminder, that area under the curve is always giving us the proportion of the population with those characteristics, and the probability that a randomly selected individual from the population has those characteristics.